Okay, so moving on from example 2, this is example 3. So in this example, you're given your supply voltage, you're given your current, a value for R1 of 4 ohms, R2 12 ohms, R3 is your unknown, R4 is 7 ohms. So again, I'll start this one by doing an equivalent circuit of 3 resistors in series. You'll see there's a video here as well in this same section that goes through the rules of series circuits and parallel circuits. If you're not sure what the rules are, it's worth going back and having a look at that. So this would be RP for these two in parallel, R3 and R4. Still 45 volts here, still 3 amps here. Coming round this direction, coming from the positive of the battery, flowing round. So 3 amps would be here as well. It's the same current at any point. So to get our RP first is our 4 in parallel with 12. So I'm just going to put the shorthand way of doing that. RP, 4 in parallel with 12. I'm going to use the same method in my calculator. 4, 1 over, 12, 1 over equals, then a final 1 over gets me 3. So 3 ohms. So 3 ohms is the value for this RP. This is what we've just worked out up here. R3, we don't know. R4, 7 ohms. Now we can use our triangle again. To get what the total resistance is in the circuit. Because we know what the total voltage is, we know what the total current is. R equals V over I. 45 divided by 3. 15. So 15 ohms. So you've got 3 there, 7 there. 3 and 7 is 10. That one must be 5. So our total must be equal to RP plus R3 plus R4. So our total, 15, which we got from here, is equal to RP, 3, plus R3, our unknown, plus R4, 7. So 15 equals 3 and 7 is 10 plus R3. So R3 must be 5. Which would R3 equal to 5. Then from that, we can do our voltages again. VP, V3, V4, which will tie in with these ones. VP, V3, V4. And our two currents. Your 3 amps comes along, hits this junction. Some of it comes along through here, I1. Some of it comes through here, I2. Then at this point here it rejoins and it's 3 amps again, and 3 amps all the way back to the supply. So we'll do our voltages first. V1, which is VP here, for our voltage across resistor 1, and our voltage across resistor 2 is VP. I, the current flowing through that part are in this equivalent circuit, times RP. So 3 times 3, giving you 9 volts. V3, which is the voltage across R3, I times R3. 3 times 5 which gets you 15 volts, V4, I times R4, 3 times 7, which gets you 21. These three should add to get you that 45, so let's just check. 9 plus 15 plus 21, 45. So they check, they're fine. The next thing that we should do is get our two currents, I1 and I2. So I1, I equals V over R. The voltage you would use for I1 would be VP over R1. I1 only flows through resistor 1. So VP, 9, divided by resistor 1 is 4. So 9 divided by 4, 2.25 amps. And your I2, which you can see there, only flows through resistor 2 and has that voltage VP across it. So VP again, still 9, and R2 is 12. 9 divided by 12 gets you 0.75. And now you know that these two added together should give you the 3. So let's check that. And that gets you the 3. So that's correct. So again, for this one, we've got all the voltages, all the currents, all the resistances. So that example is complete.